Number 15 was about circles and then some part of trig. So part A says, a chord AB subtends an angle theta radians at the center O of the circle of radius R. Now try to sketch. This is my circle, this is my center, of course this is my radii. These are my two radii. The area of the circle is 3 times the area of the minor segment AB. Show that that's true. Now the chord is a line that joins two ends, of course, of the circle. So my chord is there. Now, if they want me to get the area of the minor segment, a chord divides the circle into two segments, the major and then the minor. Now, this is my chord AB. Now, this is the major segment. From here up to here is the major, and this one is the minor segment. So, this one here is the minor segment. Now, they want me to get its area. Now, we know that area of the sector. To get the area of this segment, I will say, I will get the whole of this is called the sector. So the area of this sector minus the area of this triangle, I'll be having the area of this segment. Now, I will need to first get the area of that segment. Now, we know that the area of the sector is given by the angle at the center over 360 times pi r squared. While the area of the triangle, if you have two sides and the angle between, you use this formula of a half AB, then the angle between them. So to get the area of the segment, I'll get the area of the sector minus the area of this triangle. I'll be having the area of that minor segment. So from there, now my area of the segment will be now the area of the sector, we said we get theta over now our 360, then pi r squared minus the area of the triangle, which is here, we say a half times those two sides, which is r times r, then times sine of the angle between these two known sides, which is theta. But what do we note? We all note that 360 note. This is a note here. We note that 360 is the same as 2 pi. I think we know that one. So if I substitute there, I'll be having this as theta pi r squared over 2 pi minus a half r squared sine theta. Of course, you see that this goes, I have, and you see if I factorize out r squared over 2, I'll be remaining with now theta minus sine theta in that order. So this is the area of the segment. Area of the segment. Now, they're telling me that from here that, they're telling me that area of the circle, area of that circle is 3 times area of the segment. So now, area of the circle, we all know is pi r squared, is 3 times the area of the segment. But remember, our area is there. 3 over 2 into theta minus sine theta. Of course, we can see that this r can go away. So I'll be having now pi equals 3 over 2 theta minus sine theta. Put this side, I have 2 pi equals 3 theta minus 3, I think, sine theta. And look at our proof. They made theta the subject. So this will be 2 pi now plus 3 sine theta, the whole equaling to 3 theta. And trivially, that's my proof. Therefore, if you want me to rewrite anyway, but the proof is already out in that order. So that's how we had to do that proof. It was very easy. Anyway, we come now to part B. Part B was saying, given that that is true, find the values of cos alpha and tan alpha. Now this one, I think you see, these two are related, but they are related with squares. So meaning, I need the squares. So how do I get squares? I'm going to square both sides. So if you say you square this side, and then you square this side. So after squaring, I'll be getting tan squared alpha. When we expand this, we get sec squared alpha minus this and this, then by 2 over 3. Now sec alpha plus, when square this, we get 1 over 9 in that order. Now, of course, we know that from the second identity, our tan squared alpha will be equal to sec squared alpha minus 1. So substituting it there, I'll be having now sec squared alpha minus 1 equaling to over 9. And I think you see this one is going away. Put this side, will be equaling, take this side, over 9. Simplify, 2 over 3 equaling 2, I think you see 10 over 9. Divide through by 2 and then by this, so that my sec alpha becomes, I think this will be 5 over 3. But we all know sec is a reciprocal of cos. So I mean that here from here, my cos alpha, if I sec is a reciprocal of cos. So if I get the reciprocal of this, I'll get 3 over 5. And from there, I have the value of cos alpha. Now they're asking me to get tan. From here, I don't waste time. I come here and I use my right angled triangle. Why? Because if I know I have cos, this is the adjacent, which is 3, then the hypotenuse is 5. And then using Pythagoras, of course, we shall see that this side is squared. Okay. A squared plus b squared equals c squared. I want my a squared plus 3 squared equals 5 squared. That my a is going to be 4. So this one gives me now 4. And clearly you can start my tan alpha becomes the opposite over the adjacent. And I think I have clearly handled that number. So then we are very easy. This number, you had like 8 minutes to do it direct. Okay, just that you needed to get a relationship between these two. That's where the square is coming in. When you square this, that's when we come to that. That's it, members. If you want the full topic for trig, visit the playlist to receive more of trig. That's it. I wish you well.